Hey, I'm Kshitij Kumar of section of Group A of MSc Cloud Computing of January 2025. My roll number is 2348-189. This is my research proposal for my research in computing subject uh, and my research project that I will be doing in next semester. My topic is TinyML. So the reason I chose this topic is because a lot of node-based technologies are growing a lot, where they are trying to distribute machine learning models into local nodes to increase the privacy and security, and also decrease the effi- expenditure of the expenses that require to run a whole model for millions and billions of people. So I believe that this technology will play a good part. So that interested me as I'm doing this for now. What is TinyML? TinyML is basically running a machine learning model over microcontrollers or MCUs. So basically, running computer over my phone uh, for to make some decision would would be considered as a tiny ML. So if there is some small, very small machine learning model that's running, not like something like ChatGPT, but maybe something that takes small decisions is tiny ML. So it also it's like technology over the edge, which is basically over the your local IoT device rather than on a centralized cloud-based system. So it's like if I can get a calculator that's let's say AI and it does something special or it does calculations for me by just looking at a picture or what I'm doing on my phone is it can be worth it. It can be said that it's a edge-based AI and it have nothing to do with the cloud. There are a few challenges that comes with it is that the memory of a MCU of or a small IoT device is very less comparatively to a cloud because cloud is very way more scalable. The energy it may require might or might not affect the battery life of your devices. So there are only very few issues that comes with it. The major issue is the machine learning model itself. That how a machine learning model can be made effective to be run in these circumstances. So this study was done to understand the TinyML framework. So yeah, this is the TinyML framework. Explore models compression techniques like Turing and quantization. So these are two techniques. We will be going through them. So Turing is basically filtering of your machine learning arguments, and quantizations are basically using integers over the characters. Optimized model for microcontrollers. So these two techniques are used to optimize the models itself to for the microcontrollers. Uh, so so there are few in our research. So there are few main components. So Warden and Sitanake was the one who introduced NEML into as their part of the thing. It was their idea that we can make something that a machine learning model to run over the IoT device and or the edge systems. Then Hen introduced and developed the technique Puring, and Jacob developed the technique quantization. Howard developed mobile nets for efficiency. So what does that mean? It's mobile network for mobile devices for efficiency. It's like again on very node-based connected systems, yep, which connects with each other, and every node have its own model running and they share data. It's a very decentralized way of saying this. Puring, removal redundant. So puring is, as I said, it's about filtering and reducing the amount of arguments passed into a model, but still maintaining a high quality output. Replace floating points with integers. So floating points are basically your decimal points. With integers are round off, so it contains less memory. So saying that one is contains less memory than saying 1.15. Trade-offs: size versus accuracy. So uh, size and accuracy, as size decreases, the accuracy also decreases with itself. So that's the only major trade-off here. So microcontroller constraints are basically issues that we recently discussed about, that microcontrollers have low on memory, have limited CPU power, and does not have too much energy or to truly do the job for the big models. How what are they planning to do exactly? Is to train, compress, and deploy and inference. That's their basic deployment flow. It's like, what are the steps to make sure that a model is successful over a IoT device. This would be it. This would be the first steps. First we train, and we try to compress it as much as possible, eventually deploying it and seeing that what are the results for the users there that we are looking at. Limited data set for micro MCU testing. It's true because there are not much data sets that are available, as we need higher accuracy of our results because it's a machine learning model, but with as low potential parameters as possible. TinyML enables intelligent devices at the edge. So it's like, if I create, as I mentioned, a calculator AI, um, which can run over my phone or with really low memory and power to be provided in it. That's something that's just amazing, and it's over just a very little device without any outside dependencies or outside factors interrupting with it. Models compression is the key, is very accurate, because as much as possible compress the model while maintaining accuracy is the key for this phenomena of for this idea. Future work is just to explore more about this architecture and try to apply it in a real world application. That's it for my presentation. Thanks a lot.